Yeah. So, welcome on our DataOps Poland meetup. Today we have our guest from. Today we have presentation about Spark and Kubernetes. So, stage is yours, guys.
Thank you very much, Tomasz.
My screen sharing. Okay, so.
Yeah, I'll take over. Great. So yeah, welcome everyone. Thank you very much, Tomasz and DataOps for having us. I'm JY, one of the co-founder of Data Mechanics. I'll say a few words about what data mechanics is just a little later. Before creating data mechanics, I was a software engineer at Databricks, so I've been working with Spark on the infrastructure side of Spark for a few years now. And so, yeah, I'm excited to share today some lessons learned to really give you an introduction to Spark on Kubernetes, and hopefully even more than an introduction, we should cover some depth. Before I dive into the topic, I just want to say a few words about what data mechanics is and how come we know stuff about Spark on Kubernetes. We are indeed a managed Spark platform, okay, just like Databricks, my former company, just like Amazon EMR, Google Dataproc, Azure HD Insight, and so on. It's a serverless Spark platform. By serverless, we mean that there are a lot of autopilot features like automated scaling, automated tuning of Spark configurations. It's containerized. It's integrated with many tools, and it's also priced. It's built based on real Spark compute time and not server uptime. So really by serverless, we mean that data scientists, data engineers should spend time, building their Spark applications, their machine learning models, their pipelines. But then once they send us the code, our platform should automate all the rest. So the deployment, the configuration, the scaling, the monitoring, and so on. How come we know about Spark on Kubernetes? Because, well, our entire product is built on Spark, on Kubernetes. So at a high level, this is our architecture. When customer want to work with us, we basically deploy our product inside their cloud account. So if they're on Amazon, we use EKS, which is Amazon Managed Kubernetes Service. If they're on GCP, we use JKE. On Azure, it's called AKS. And then on this Kubernetes cluster, we have one service running there all the time, like with our code running there. We call it the gateway, and it's the entry point for launching Spark applications. And so you can do that either in an interactive way by connecting Jupyter notebooks, or by submitting applications programmatically using a script, using Airflow, or using any kind of other scheduler. I just mentioned Airflow because we have a special connector. Once your application hits the gateway, we're going to actually launch, configure, scale it, and give you access to a monitoring UI. And also, I should mention, but we're going to cover this later, this isn't a fixed size Kubernetes cluster. This Kubernetes cluster is going to automatically scale, add nodes, remove nodes based on the load. And that's the only way really to make Spark efficient, cost efficient in the cloud. The reason we're deployed in our customer's cloud account is because this way the sensitive data doesn't leave the cloud account, so it's secure. In fact, internet connections, both inbound and outbound, can be restricted. But enough about data mechanics. Now let's dive really into Spark on Kubernetes. And so we'll start really high level with the core concepts, the architecture, how is Spark on Kubernetes different than Spark on Yarn. Then we'll go into more, the meat of the presentation with production tips to run Spark on Kubernetes, go over performance, stability tips, go over monitoring. And in the last shorter section, we'll talk about some of the future works for Spark on Kubernetes and kind of give you an opinion of whether this is interesting to you or not. Before I actually dive on Spark on Kubernetes, maybe I should just mention what Spark is. I presume most of you are familiar, but maybe some of you are not, or not using it, or wondering how it compares to other frameworks. So Spark It's a distributed analytics engine for big data. It's open source. The reason Spark is popular is because it's really fast. You can process huge amounts of data really quickly. Um, it's easy to write Spark application because Spark has these high-level APIs. The most popular one is the Python. It's called PySpark. Scala and Java is the second one. Obviously, SQL and R are also popular. And then the last reason why it's really popular is it's very versatile. It's sometimes called the Swiss Army knife of big data. So the most common use case is typically data engineering, also called ETL. Interactive data exploration, typically from notebooks is popular too. More advanced data science use cases like machine learning. And then streaming is more rare, but also definitely a common use case for Spark. And obviously, Spark can read data from many different data sources. So Tomasz was talking about a few different technologies earlier. Typically, if I should compare it to BigQuery, who's coming up soon, BigQuery is only SQL, which is in some sense pretty powerful, and it's pretty easy to write SQL, but less flexibility than Spark, because Spark is a real programming language. You could define Spark. You could reuse some of your own libraries, build your own PySpark libraries in Python, do advanced machine learning, have user-defined functions, pandas user-defined functions. So typically people move from a framework like BigQuery to Spark when they want the extra flexibility of Spark. Now, this talk is about Spark on Kubernetes. So where does Kubernetes fit within Spark? It's a new cluster manager for Spark, okay? Because Spark is going to take a query and it's going to divide it into tasks, and then it's going to run these tasks on a cluster, so a set of what we call Spark executors. But Spark is not responsible for launching these executors or the containers it runs on. For this, it needs a cluster manager. So that's what Kubernetes does. Before Kubernetes, there were already 4 cluster managers. Standalone, which is the one that's built in with Spark. Apache Mesos, which was once pretty popular, but is less used these days. And Hadoop Yarn, which is really the standard, and that's one of almost all the managed Spark platforms run on Yarn. EMR, Google Dataproc, Azure HD Insight, Cloudera, Hortonworks, and so on. Kubernetes is the new kid in the game, and it's Spark can natively run on Kubernetes since version 2.3, so pretty recent. And Spark on Kubernetes has had other improvements in version 2.4 and in the most recent 3.0, even bigger improvements, and it will be actually declared generally available GA with the next version of Spark 3.1. So what is the architecture of running Spark on Kubernetes at a high level? So first, as a user, you're going to submit an application. And when you do this, you directly talk to Kubernetes. And then once you submit your application, Kubernetes is going to first start the Spark driver. It's on Kubernetes, we're going to call this a pod, which is basically a container to make things simple. And then the Spark driver is going to say, okay, I need 10 executors. Give me 10 executors. And for this request, Spark driver is going to talk directly to Kubernetes, which is going to indeed schedule, create these executor pods, notify the driver that when the pods are available, and as soon as they're available, the driver is going to schedule these tasks. Start actually running tasks on Spark executors. And this process can happen dynamically, automatically, if you enable what we call dynamic allocation. So the number of Spark executors could dynamically scale up and down based on load. I'll get to this later. There are 2 ways to submit Spark applications. The vanilla way is called Spark Submit. This is really included in Spark main open source repo. I'll show next slide what that looks like, but it's basic, it's simple, but application management is kind of manual. So for this reason, many users choose to use another open source project called Spark-on-Kubernetes operator. This was initially developed by Google. Now it's open source. It works on any platform. It's not specific to Google or GCP. And what it provides is basically Spark applications become a Kubernetes object that you can manage with typical Kubernetes tools. And so it's an object you can describe, you can configure. There's additional tooling to read logs, kill app, restart apps, schedule them. So I would really recommend actually using the Spark-on-Kubernetes operator. The only downside is, well, it's something additional you need to install, and it requires a long-running system pod. So basically, it requires one pod for the entire cluster that's going to be running all the time. That's going to be watching some Kubernetes events. Just one slide to kind of show you the two methods, what they look like in practice. So Spark submit is the same command whether you're running on Kubernetes or on Yarn. The only difference here is this K8s. This is what tells Spark submit that it's talking to Kubernetes. And from then on, if you want to do anything else, you're going to need to be interacting directly at the pod level. So you could, for example, list your Spark driver by doing this. You could read its logs by doing that. But it's pretty manual. You need to interact, as I said, at the pod level. On the other hand, we have Spark-on-Kubernetes operator. First, your entire Spark configuration will be in a YAML or another Kubernetes config file. And then a Spark application becomes a Kubernetes object that you can list, that you can describe, that you can configure as a Kubernetes object. And yeah, with it's typically, some features are much more simple, like config tabs, attaching volumes, and so on. Okay, now that we have a high-level overview of what the architecture looked like, let's compare it. Let's compare Spark-on-Kubernetes to Yarn. So how different is it? First, I would say it really, like, one of the biggest differences around dependency management and the fact that Kubernetes is going to natively run Docker containers, while Yarn until recently didn't have that support, and even today it's pretty hard to run Docker containers on Yarn. So what this means is, typically when you work with Yarn, you're going to take control of your environment using init scripts or using AMIs, which is really the image of the raw machine where Spark is going to be running. And on Kubernetes, you're going to be using Docker containers, which give you more control over your environment. You're going to be able to run your Spark app on your local machine or on your testing environment or on your dev and production cluster, and know that it's going to be exactly the same environment, which is nice, more stable. The other difference is in terms of isolation. So with Yarn, you have a global Spark version, you have a global Python version, you may have some global dependencies. So if you're sharing a Yarn cluster between multiple Spark apps and they want to use different versions of the same library, maybe they're going to clash. On the other hand, with Kubernetes, each Spark app runs in its own Docker container and could be using a different Spark version, different Python version, and so on. Let's move to maybe the next. So at a high level, I would say Spark on Kubernetes gives you at the same time full isolation between concurrent apps, and also there's a certain cost efficiency because the Kubernetes cluster is shared, and so the underlying nodes that support multiple Spark apps are shared. What this means is, as soon as an application doesn't need a resource, we can remove a container from it and allocate the space to another application that needs it. So you kind of have the sharing, the cost efficiency of sharing an infrastructure without the downside of isolation issues. Another reason why people are interested in Kubernetes is obviously the ecosystem. Oftentimes, people already use Kubernetes for other part of their infrastructure. Okay, maybe they use Kubernetes to host their web servers, and so using the same tool for both their main application and their big data system is useful. It's also a cloud agnostic abstraction. Okay, Kubernetes is available on each cloud provider, and then beyond that, there are lots of tools that are going to obviously integrate with Kubernetes, and so integrate with Spark and Kubernetes. Thinking some CI/CD tools, some logging, monitoring, security, um, and and even more. So that's another reason why people are interested in Spark and Kubernetes. Um, Now, if you look at performance, this has been, at least early on in the early days of Kubernetes, this was a criticism. People were afraid you couldn't get the same performance on Kubernetes compared to Yarn, because Yarn has been around for so many years, kind of mature. And well, it turns out, as long as you don't make some configuration mistakes that could severely impact performance, and that's true for both cases, you're going to get the same performance. We ran some benchmarks and got really the same performance between Kubernetes and Yarn, as you can see in this graph. I know the Amazon team also ran some benchmarks and got very similar results. So within an application, you can get the same performance. Obviously, at a high level, if you look at all your Spark applications running concurrently, the fact that on Kubernetes, the resource sharing can be made really efficient, I think means Kubernetes could kind of reduce your cloud costs compared to managing single tenant or multi-tenant Yarn clusters. But for a specific app, there is no performance difference. So now that we've covered kind of the high-level differences between Spark and Kubernetes, let's actually dive in and see what working with Spark and Kubernetes looks like, and give some performance stability tips. So maybe let's get started and jump right into how to configure your Spark application. So this is one common mistake you run into as you get started. You say, oh, I want to I have Kubernetes node that have 4 CPUs, 4 processors. And so I'm going to submit a Spark application that is going to use all these resources. And so I'm going to submit an application with this configuration, Spark executor cores equals 4. But if you do this, you're going to see that your Spark app is actually stuck in a pending state. And because if you look at the Kubernetes logs, you'll see that Kubernetes is not able to place the executor anywhere. Why? Well, because actually, indeed, your node has 4 CPUs, but some resources is going to be reserved for Kubernetes and system daemons. So maybe this is something you can describe when you describe your node, but let's say maybe 5% is taken by them. And then, so the remaining space is called node allocatable, and even that may not be entirely available to your Spark app, because maybe your company is running some daemon sets. Daemon sets is a Kubernetes object, and it's basically well, a set of daemons who are going to be running on each node. You could use this for security, for log collection, and so on. Typically at Data Mechanics, we use daemon sets for log collection. And so they could be taking some space. So what this means is, in the end, maybe you only have about 90% of your capacity. In which case, if you want the app to run, you should give this 3.6 CPUs. And indeed, you can do that. You can configure Spark with this config, where you say, oh, I want to request 3.6 CPU cores. And you'll see that you actually need to provide these 2 configurations. So the second one is going to tell Kubernetes how much CPU to allocate to each Spark executor. And the first one is going to tell Spark how many tasks to run in parallel. And you see that the 2 numbers here do not need to match. In fact, some people decide to make this number much bigger than the other one below, which means that under the hood, Spark tasks are going to be sharing CPUs, or let's say one processor is going to be running multiple Spark tasks. And this could actually sometimes make a performance improvement. It's called oversubscription. And if your app has a low CPU usage, it could benefit from this over subscription. By the way, like my talk is going to be really talking about what it's like to run Spark on Kubernetes open source. In our platform, Data Mechanics, a lot of these issues I'm describing, we fix them so that you don't need to compute these numbers. We're going to be automatically tuning the size of your apps and make sure your Spark executor bin pack efficiently within nodes. But I want to mostly focus on the open source case. Now let's talk about dynamic allocation. Dynamic allocation is when a Spark driver is going to dynamically add or remove Spark executors based on load. Typically, how does it work? If there are Spark tasks that are pending, so they're waiting to be running on some executor, Kubernetes is going to decide, oh, I need more Spark executor. Give me 1, and then give me 2, and then give me 4. So it's going to go with exponential steps. And then vice versa. Maybe if an executor is not running any task for like a minute, or it's a configurable time period, but let's say a minute, it's going to kill it. And so your app is going to downscale. And so typically dynamic allocation is a really cost efficient. It's really good to make your apps more cost efficient, particularly if you're running notebooks, because interactive workloads tend to be more bursty, and you're going to run some code, then go to a meeting, and so it's important your cluster automatically, your application automatically downscales. And so what I wanted to say is that dynamic allocation is now available on Kubernetes since Spark version 3.0. For earlier Spark versions like 2.3, 2.4, it's not available. The reason, the way it works on Kubernetes is that the driver is going to be tracking which executor are storing active shuffle files. So this is called shuffle tracking. And this is important because during downscaling, it's important not to remove an executor that was storing an active shuffle files. Because if you do that, let's say you kill this executor 1, well, in the other side of the shuffle, you're going to be missing this data, and so it means you're going to have to recompute the previous stage to reproduce the data. Finally, dynamic allocation works well with Kubernetes autoscaling. So, dynamic allocation is the fact that each Spark app can dynamically add or remove executor. And then Kubernetes autoscaling is the fact that Kubernetes is going to add nodes, so add machines to the Kubernetes cluster. So typically in our platform, we enable both. And yeah, when there is capacity, so when there is a node that's ready on the cluster, it takes maybe 10 seconds to start a Spark container. Otherwise, if you need to get a new node from the cloud provider, it typically takes a couple minutes, sometimes less, one. It kind of depends on the cloud provider, the region, the instance type. And Kubernetes autoscaling, on GCP, it's provided by default in their UI, and on AWS and Azure, you need to install a project called Kubernetes Autoscaler. When you see links like this, I will be sending the slides so that you can follow them afterwards. Yeah, now let's talk about one optimization we built at Data Mechanics to kind of speed up dynamic allocation, because maybe you don't want to wait 2 minutes. If you just open up a notebook, you want to immediately get your Spark driver and start running code. So for this, we use a mechanism called pause pods. So pause pods are low priority pods that basically do nothing. They just sit around. So let's understand through an example what this means. Let's say you have a Spark driver and currently has 4 executors, and then maybe you need more. There are a lot of pending tasks, so dynamic allocation is going to say, I want 1 more executor. So it's going to ask Kubernetes for an executor. Since the pause pod has a low priority, Kubernetes is going to say, I can kill this pod and use the space to run a Spark executor. And so the space. And so this is going to happen really quickly because starting a container takes just a few seconds. So really in 5 seconds, you're going to get your new executor. And then Kubernetes is going to try to place the pod on a different node, which will trigger a scale up of the Kubernetes cluster. And so this is going to take maybe a minute or two, and the pause pod is going to be there. And so basically this pause pod mechanism is a way for you to over provision your cluster a little bit, which means you're going to pay a little bit more cloud costs. But what this means is you always have some capacity, and starting a notebook will always take just 10 seconds. So this is something we built internally, and here are you'll see the link with some docs for how to do this. Now let's move to an important performance tip, and this is about the shuffle, which I already mentioned earlier. Maybe I'll actually, sorry, I'll just go back to this image to explain what Spark shuffles are. A shuffle is when Spark needs to redistribute the data across the entire cluster. So you had some data on each Spark executor, and for some reason it needs to move the data around completely. This is a pretty expensive operation because there's a lot of I/O. Obviously, you're going to be sending, receiving data across the entire cluster. However, sometimes they are necessary. Maybe in your code, you just run a group by key. Group by key means that the data is going to be indeed grouped by the new key you provided. And so the new, this could produce like a very random shuffle. So let me go back to the slide. So it's an expensive operation, and so that's why shuffle performance matters. Typically, I/O is going to be the bottleneck when you have large shuffles, because the data is going to be written to the disk. When it's large, it doesn't fit in memory, so it's going to be written to the disk, and so that connection is going to be the bottleneck. So to increase the performance of shuffle, we have two recommendations. One, when it's possible, you should use local SSDs, which are definitely much faster disks. And then you're going to mount these disks and make sure Spark uses them. Okay, it's not enough to just mount them. You need to provide what we call the host path, which is here, which is telling Spark how to use this disk. Without this configuration, it's not going to use them for shuffles. And this can have huge performance gains, up to 10x on specific workloads. There's a blog post where we go over this in more details and also show some results on the benchmark. This is actually part of one of the image in the blog post where we ran the TPCDS benchmark, and you can see here the impact of a certain disk change. And so depending on how much shuffle was produced in the query. And so you see in this graph that the bigger the shuffle, the bigger the ratio between the two query durations. And so in this case, this is not a difference between local SSDs or not. These were actually traditional disks, but disk size also matters. Okay, the bigger the disk, the bigger the throughput. And so for these queries, for certain queries, we're able to get a 5x performance boost by just using bigger disks. So yeah, really, these are the kind of performance tip that really matter once you want to run in production. Maybe a last one around the performance of I/O. Oftentimes, when you run Kubernetes in the cloud, you're going to be reading and writing data to and from an object store like S3. So this is not specific to Kubernetes, but it's important to say it. There's a specific committer for S3 that's really optimized for it, and that will give you a significant performance boost. If you're not using S3, if you're using another object storage, you can check if they have a Spark committer, and if they don't, then at least you should use this configuration, the file output committer algorithm version 2, and this is basically a new way that Spark will write to object store, and that will be more efficient than the version 1. yeah, under the hood, the reason why we have this is because originally Spark was designed for working with Hadoop file system, HDFS. And once we started running it in the cloud and use object store, we treat the object store as HDFS, even though they have really different performance um, profiles. And so that's why if you just use the default, which is the version 1, you're going to have poor performance. Now, we've talked a little bit about really the performance of your Spark app. Now, maybe let's talk a little bit about the cost side. This is something that a lot of customers ask us and use. You know, spot nodes or preemptible nodes, they can reduce your cloud costs by 75%. In exchange that they're not as reliable. Spot nodes, by definition, can be taken back by the cloud provider at any time. So what you want to do is you want to make sure that the Spark driver is not placed on a spot node. Only Spark executors can be placed there, because if the Spark driver goes away, this kills your application. Spark cannot recover from losing its driver. However, it can, and it does recover from losing an executor. So you need to constrain the Spark driver to be on an on-demand node and only allow Spark executors to be on preemptible nodes. We've implemented this using node selectors. I can't go into too many details because it's kind of implemented in a different way, whether we're on Amazon or Google or Azure. But basically, we have a custom label that we define on node pools to note if they're on demand or spot. And so then the node selector, you can say, oh, I want the driver to be on an on-demand node and the executor to be on spot. Now that we've seen this kind of critical performance and stability tips, let's look at monitoring. So how do you know what's going on in your cluster? There are.
Sorry to interrupt. We have a couple of questions. Do you want to maybe we can go over them quickly and then get back to it? That way
that sounds great to me. Yeah, at least a few of them.
In between. Yeah, definitely. If someone has any other questions, you can also raise your hand or just write them in the chat and we'll get to them. Yeah. So we have a couple. There were some more from before that were answered. So we have one from Harpal, and he was asking if they want to migrate from Spark-on-Yarn to Kubernetes, if there are any tips. I think we maybe covered part of it here, but if you have any more specific.
Yeah, this is something we do with a lot of our customers. So at a high level, first, your Spark code is going to stay the same. That's good. That's important. The main changes are going to be around how to package dependencies. So basically, we typically recommend to start Dockerizing your apps. You could either package your dependencies by building a custom Docker image for each of your app. And so in which case, you probably want to make this a script or a CI/CD that automatically does this. Or you could still install dependencies by referring them, just specify your dependencies as a path to S3. So push your, build your libraries, push them to S3, then give an S3 path. So that's one thing. Beyond this, at the end of the presentation, I have a high-level guide for how to get started. But beyond this, the other change will be around Spark configurations, because Yarn and Kubernetes are different, and so how you size your pods is a bit different. But I think we also covered part of that. Yeah, and other than that, I think the guide at the end will help, and we have some more blog posts that could also help.
Yeah, okay. There were two questions from Pavan and Ravi. I think those were covered in the presentation. There's one more. If we have, Ravi was asking if we have client mode and cluster mode in Kubernetes. And then there's one more question from Maciek, and then we can continue, I think.
Yes, yes, I am pretty sure there is a client and cluster mode in Kubernetes. Within data mechanics, we use only cluster mode, but I'm pretty sure client mode works as well.
Mm-hmm. Okay, and I think this one is probably related to one of the last slides we were talking about from Maciek. So he was asking if we've tried using Kubernetes with Spark and Minio. I'm not sure if I'm pronouncing this correctly. So it's an on-prem S3 alternative. So this is as an alternative to HDP or say the CDP solution.
Yeah, so data mechanics is only available in the cloud, and so our customers don't use Minio. But I heard of companies using Minio with Kubernetes in production. I believe I don't want to be quoted, but I believe Apple is one of these companies, and there are some large companies doing that. And so yeah, definitely it works.
All right. I think that's it for now. But okay, from Ravi asking if, well, like, where does Spark store metadata for Kubernetes? I think we can take this one and then continue.
Metadata. Let's see. You probably want to use the metastore, and so the metastore could be stored. Could be a database or could be a custom metastore. Yeah, oh great. I see Pratik also answered other questions. So yeah, similarly to running Spark on Yarn, you could set up a metastore for storing metadata. Great. Yeah, thanks a lot. I'm glad this made a little break and made this a bit more interactive.
Yeah.
I'll move to monitoring, which is an important question too, because you want to know what's going on. So unfortunately, most Spark platforms, as I mentioned, are not deploying on Kubernetes, which means, I think we're one of the few. I think Dataproc also has an alpha version. But so if you want to run Spark on Kubernetes, unless you're going to be using us or Dataproc, you're going to be running this on open source, in which case you're kind of alone. I mean, you kind of have to re-implement some of the monitoring stuff. First, one of the very common tool is the Kubernetes dashboard. This is not specific to Spark. This is a general purpose monitoring tool for Kubernetes. And you're going to be able to see all your nodes, all your pods, to see in real time their memory usage, their disk usage, their CPU usage. On some cloud provider, it's automatically there. I think on JKey it's there. If you're using Amazon on EKS, it's not, so you need to install it, and there's a link there. Obviously, the issue with this tool is that it's not specific to Spark, so it will be kind of hard to reconcile what's going on Spark with the graph you see here. The other issue is it doesn't persist the data, so when the Spark app is completed, you're going to lose these graphs for Spark executors. Or there are other ways to persist it to a time series database, but this is more work. The other very common tool is the Spark UI. So the Spark UI, when it's for a live application, it's directly served by the Spark driver. And if the Spark application is terminated, there's also another way to get it back. For this, you need to run the Spark history server. So first, for a live application, typically the most common way is just to port forward a certain port from your laptop to the Spark driver, which means that when you will open up your browser on localhost 4040, this will actually direct you back to the Spark driver port 4040, and so which will serve the Spark UI. Now, for terminated apps, it's a bit harder. What you want to do is you want to persist the Spark event logs, which is a certain type of log written by the driver, to an object store. You can use a Spark configuration for that. And then you want to install the Spark history server, which is a JVM application on your Kubernetes cluster. There's a Helm chart for that, and configure it so that it's able to read your event logs. Obviously, the Spark UI, I mean, it's a decent tool. However, it's not very user-friendly, and it also doesn't have the system metrics we were mentioning earlier. So you don't know if your app is going to be bottlenecked or on CPU, on memory, on disks, on I/O, and so on. So this is the reason why we started to build a replacement for the Spark UI. This project is not released yet, but we hope to get a private beta out by the end of the year and the GA early next year. And really our goal is to make Spark more accessible to help people, even beginners and experts alike, understand really what's going on, what's the bottleneck. And so it's going to have both Spark metrics, so like a view of your Spark jobs, and also system metrics, so you know what's the CPU usage, the memory usage, and so on. And obviously it's going to be available to the users of our platform, but we actually want to make this available to the entire Spark community. So you could use the data mechanics on top of, I don't know, Amazon EMR if you're using EMR, or Spark-on-Kubernetes open source if you're just running Spark-on-Kubernetes open source. So this is something we're excited on. Great. If there are some questions, we could stop. Otherwise, I can get to the last part.
Yeah, there's one from Richard, which is who's asking if it's possible to do caching, I think, with Spark and Kubernetes, but I'm not sure. Because the question is it possible to do cached in Spark with Kubernetes?
Yeah. Yes. So caching is when you computed, say, a data frame, and you want to store it in memory, so that when you want to reuse it multiple times in your code, it's going to be using this data directly from memory and not recomputing it. And yes, it's definitely possible with Kubernetes, the same way that it works in Yarn. And so it's going to first save the data to memory. If there isn't enough place in memory, it can also spill to disk. Definitely possible. So I'll move on to the conclusion. Thanks for the questions. So first, Spark on Kubernetes is going to be declared generally available with the upcoming version of Spark, which is 3.1. So today, if you look at the Spark on Kubernetes documentation, it says that it said that Kubernetes is currently experimental, so this is going to be released. And really, this is because a lot of improvements have come in the most recent versions, including 3.0, typically dynamic allocation. And there are more exciting features that are going to be coming in. So this is one of them. It's not certain yet that it's going to be in 3.1. It may be in 3.2 because it's still work in progress. But this feature will basically use remote storage to persist shuffle data. So what does this mean? Let's go through an example. During shuffle, some executor will first write a shuffle file locally, and we call this the map side. And then on the other side, there's the reduce side. There's another executor who's going to fetch this file. So with this feature, first the file will still be written locally, but then asynchronously, the file is going to be copied to an object store like S3. We do this asynchronously so that it doesn't impact the performance of the shuffle on the map side. Then on the reduce side, if for some reason the other executor was gone, instead of fetching the files from the executor, we're going to fetch the file from S3. So really the goal here is to have unconstrained dynamic allocation. Okay, so we don't need to track which shuffle files are where. We can always remove a Spark executor because we know we have S3 as a fallback. And beyond just dynamic allocation, it would make Spark resilient to node loss. Okay, so if you're using spot nodes and the nodes goes away, well, doesn't matter, shuffle has been saved. If for some reason Kubernetes needs to update your node, and so some maintenance and the node goes down, or the cloud provider sometimes also have these maintenance events and the node goes down, well, it doesn't matter. The shuffle file is saved. So this is pretty exciting. And there's another feature which I think will definitely make it for Spark 3.1, and it's a bit related. It's again around the stability of making Spark more reliable even when some nodes go away. And so this feature is called better handling for node shutdown, or graceful decommissioning. And basically, when an executor pod needs to go away, maybe because Kubernetes decided it, maybe because it's a spot termination. Spark is going to be aware of it. So Kubernetes is going to tell the executor pod, which is going to tell the driver, oh, please decommission me. And so what this decommissioning means is that first, the Spark driver will stop scheduling new tasks. Okay, it's not worth trying new work if the executor is going to go away. And second, it's going to copy cache data or shuffle files to other executors. So again, this will be pretty useful, in particular if you're using spot nodes. The cloud provider now gives you like about a 2-minute warning before it kills your spot node. And so this means you can use this 2-minute time to save your work and make spot nodes much easier to work with. So yeah, this is it for future works. Maybe just as a way of conclusion before we open up to Q&A, what are the high-level pros and cons of Spark on Kubernetes? Note that we are biased, because we definitely chose Kubernetes for our platform. However, the pros that you will read, everywhere is first the native containerization with Docker, also the fact that it's a single cloud-agnostic infrastructure that you could use for your entire tech stack. And finally, the efficient resource sharing from Kubernetes that will give you at the same time cost efficiency and resource isolation. On the negative side, if you're new to Kubernetes, there's a learning curve, definitely. And there's a lot to set up yourself because unless you use a platform like us, there's a lot basically to set up. The next slide, and I think this answers one of the questions, kind of describe at a high level what you need to do if you want to get started with open source. So you would create a Kubernetes cluster, also a Docker registry, set up the networking, set up the node pool, set up your disk size. Maybe I would recommend it, install the Spark operator, install the Spark history server, collect and persist Spark application logs and metrics. Some of this could be done by the cloud provider, but typically you will re-implement some stuff, typically Spark event logs. And then, so this is like a one-time cost and also some pieces you'll need to maintain. And then there is more like the dynamic, the work that you need to do over and over to make your applications performant and stable. So pod sizes, to make sure, pay attention to bin packing, optimize I/O, pay attention to shuffle issues, or install the right libraries. Yeah, auto-scaling, dynamic allocation, spot, or preemptible nodes. If you're interested in getting started, feel free to check our website, potentially book a demo with us so we can explain how our platform can help you with that. But really, at a high level, like I'm personally convinced that Kubernetes has taken the traditional software engineering world for some good reason. It means it brings many advantages, many good practices, and it's time the same thing happens for big data. Great, yeah. So this is our website. Feel free to also connect with me on LinkedIn and Twitter, and yeah, let's see if there are more questions now. Thank you.
Yeah, thank you for a great presentation. And if you would like to ask any question, please use the raise a hand button.
Great. Feel free to unmute yourself. I mean, I think you can.
Yeah, it'll have to be to raise their hand, I think, and then, yeah.
Oh, got it.
But not, I don't see.
Nicholas, you had turned your video on. I'm not sure if you were trying to ask as well.
Oh no, it was on the whole time. But actually, I have a question.
There we go. Sorry, I thought it was. Yeah, I thought it would be highlighted. Usually, the videos are on the.
No, it's all right. So I've been using Databricks for a while, and I'm curious about the value proposition of data mechanics versus Databricks.
Yeah, of course I can answer that one since I worked at Databricks before. I would say Databricks is an end-to-end data science platform with many features included, like hosted collaborative notebooks, hosted job scheduler, ML flow integration. So if you need all these tools and you are okay with paying the price, it can be a good fit for you. Many organizations find that they don't really need hosted collaborative notebooks because they like their Jupyter notebooks and have some workflows. They don't really need a scheduler because they may be using Airflow internally, or they may be using Amazon Step Function, Google Cloud Composer, and so on. And they just want Spark to be managed because unless you're a huge company like Google and Facebook, you don't want to be managing Spark infrastructure yourself. And so I think that's where we come in. We really focus on Spark infrastructre management, which is, from my experience, the core pain point. And on this front, we go further than Databricks. Our auto-scaling is superior, our automated tuning, so the fact that we're going to be tuning Spark configurations, container sizes, disk sizes automatically, this is something they don't have. The fact that we're deployed on Kubernetes and they're deployed on standalone, which is basically a proprietary cluster manager. So today we work mostly with startups, SMBs, up to a few teams, companies, and both data science and data engineering workloads. Our customers tend to, indeed, on average, do a bit more data engineering than maybe Databricks, which is very famous for data science. Yeah, did I answer your question, Nicholas?
Yeah, that makes sense. Thank you.
I'm glad. Yeah, that's a great question.
Okay, there is another question from Maciej. Do you use custom Spark runtime, custom Spark runtime like AWS in their VMware?
We do provide built-in Docker images that have some optimizations, typically some libraries that will optimize I/O, but we don't have proprietary Spark version like EMR or Databricks. From my experience, sometimes they can really solve a specific use case, but on average, not convinced that their custom Spark runtime has such a huge improvement. Yeah, we really believe in open source, so today we try to stay aligned with open source as much as possible. Maybe in the future will change.
Great. The next question, it's Pratek. Are you there?
Yes, I'm
cool.
here. My question is mostly regarding the data mechanics platform. Like when we use this platform to deploy resources on a Kubernetes cluster, what kind of access, as that product has and your team has on the cluster?
Yes, when our customer signs up, they give us permission on the AWS or the GCP or the Azure account that we need. So we have an IAM role with a set of permissions that we need. And indeed, these permissions will let us create and manage the Kubernetes cluster. That's part of the service we provide. There are lots of open source software to maintain, keep up to date, keep the Kubernetes cluster up to date. And that's, yeah, so we're going to be using these permissions to push releases every 2 weeks with new features, updates, and so on. Yeah, I can send you the specific IAM role. However, these permissions are scoped to the account that we're going to be deploying. So typically, you could be creating a new account just for data mechanics, such that we don't have, we don't need permission on your data or on your production Amazon account.
Sure. Okay. Cool.
Okay. Next question from Ravi. Not sure if you would like to unmute yourself, or I can read it. Okay, so I will read it. Can we able to use data lake?
Yes, Delta Lake is an open source technology framework that's basically going to be an intermediate between S3 and Spark, and this works also with Spark-on-Kubernetes. It works also with data mechanics.
Okay, and I think one of the last questions: do we have REST API support for Spark in data management platform?
Yes, you can submit Spark applications programmatically through a REST API. You can also connect notebooks. Yeah, the documentation of the API is on docs.datamechanics.co, and it follows the Spark-on-Kubernetes Spark Operator API.
Good. Last few seconds. Questions? Any?
No
Good.
questions.
Yeah,
Thanks for presentation.
Oh, Ruslanas. Hey, Ruslanas.
Hi, Tomasz.
Yep. Shoot. Ruslanas, your turn if you have any question.
I have no question. I just want to thank presenters for great presentation.
Cool.
Much for joining.
Yeah, guys, once again, thanks for the great presentation.